So thank you for joining today. This will be a demonstration on how we can use our MB Precise Sonar plugin analysis to generate Confluence diagrams that describe our ACE and message broker and IIB applications and architecture. This allows for a common place for us to help understand and describe our applications that can help share knowledge between developers, users, business analysts, and operations. But so we can understand the last step that I'll be showing you, which is the creation of these diagrams, we need some background on SonarQube. So what is SonarQube? And it's an extensible platform that allows teams to find issues in applications code and manage technical debt. It consists of a UI, which you can see here, an analyzer, which is essentially the thing that takes your code and understands it and then produces the rest of the functionality, and a database, so that what happens over time is that information about your code is stored, and then you can determine, if the quality of the code is improving or getting worse over time. You can find hotspots, and it also feeds the UI that you're looking at here. So I mentioned it's extensible, and so what we have is we have a plugin that does the analysis of IIB code. So ESQL, message flows, subflows, message sets, MQ definitions, and a few other file types. So what we get when we do an analysis of SonarQube is metrics, which you can see here. So for example, if a metrics might be the number of files, which isn't all that useful, or it could be the number of nodes, or it could be the length of a summary of the length of the nodes in a flow. For example, which flow has the longest consecutive nodes, which is useful for looking at, say, things like performance. The next one you get is something called rules. So in this case here, rules are what you would normally look at as bad things, so violations of where you've deviated from a coding standard or where you've potentially got buggy code. So in this case here, we're looking at a violation, and we've got credentials in plain text, which means anyone reading the code can pull those credentials out and make use of them and abuse them, which is a potential security issue. Test coverage. Test coverage tells us how much of our code's been tested. So in this case here, by our automated testing or regression. In this case here, we can say the green bits say that this particular line of code or this particular branch is fully covered, and we can see here we've got 2 additional branches, and else where we can see those the if condition has been met and tested, and the else condition has been met and tested. What we're seeing here, the red mark indicates that this particular procedure has never been called by our test cases. And the last one is duplication. What this tells us, as you can see here, is it tells us there's a couple of lines of code that's duplicated in another file in our project. Now, we do need to take into account how we write ESQL code with duplication, and that there's the common pattern where particular blocks of code are always duplicated within all our different modules. So in this case here, the copy is picked up on the copy message headers. But oftentimes we'll actually pick up on real code duplication blocks. So now, as we have all your code already, when we run the analysis to be able to do these checks for coding issues, we can add some extra value by being able to extract the information about your code base and how your code works. So for this, what we've generated is what we call a summary. So in this case here, this is a summary of a project as a HTML page. And you can see here in the summary, we've got some information about your code. So we've got here the details about all the flows that it's found. We've extracted all the comments and documentation about each flow. We can navigate into a flow where we can see the notes, which I mentioned before. We can see what nodes are in there. We can also see the interactions to other flows. Now that we do this for a number of things, we've got queue summary, so all the queues used. So in this case here we can see where a queue is being used, We can see this queue, this flow uses a queue and writes to a file. We can see Kafka consumption, we can see IMS requests, we can see all data packages. Let's find all Java. Let's have a look. Oh, no. Let me find all Java methods and all stored procedures. So really useful stuff to help us understand our application code. Now this was the first version, and we've been through a few iterations. The first version is basically a static HTML page. The next version we generated was basically the equivalent of GitHub page. Is the case of GitHub markdown pages. So what we do is we generate a page that summarizes the same information in your project if you're using GitHub. So then you've got your code and a summary of your code as markdown. We've also done something similar with GitLab pages to help summarize this information. We've also done something with Backstage. Now these are all very useful tools that give us the potentially can be used by lots of different teams to help share knowledge, but it's not completely useful to all the stakeholders. So we don't have, generally speaking, our users and our product owners. If we're doing like an agile a process, we've got a product owner standing in for our users to help understand things. We might not be having them go into Backstage. We might not be having them work in GitLab, for example, or in GitHub. So ideally what we want to do is meet our users where they work. Now, Confluence is a fairly common corporate tool, and a lot of organizations already put a lot of organization knowledge, business knowledge, requirements gathering, and other artifacts into Confluence, which makes it easy to share. So if we can get the application knowledge into Confluence, then we can share it. So when we run an analysis, we use the property file that describes a bunch of things about how we're going to run this analysis, but in this case here what we're looking at is one that's going to tell us how to put this information into Confluence. So inside this Confluence, we've got inside this configuration, we've got a reference to our instance or our space inside. I won't use the same space. I won't use the word space because it could be a little confusing. Basically, our company's Confluence setup, which is our base URL. We have username and password, so we can log into it to be able to create these diagrams and upload this information. A space, because we might have multiple business lines, and we want to say this is where we're going to put our technical information about IIB and development, so we know that it goes with the rest of our technical information, and the base page. Now the base page is important because what we're doing is we're generating and regenerating these diagrams depending on how often you need to do it or want to do it. Whether it's on a merge request or when something goes to branch or even manually. So we're regenerating these things. So we want to make sure we don't override or conflict with any manually generated pages or manually generated content, because that would mean potentially we're going to wipe out something that a user has put in themselves that they want to keep. So we keep our generated or partially generated code and our manually input knowledge separately. It's important that we do this in an automated way because it means it's going to be always relevant. Now, someone could go through and do all these diagrams manually, but it wouldn't take long for there to be drift between what the developer has done and what the diagram actually describes. So in which case if you've got a diagram that describes something that's not the business process that's currently there, then it's virtually useless as a sharing tool. Now the other important thing is about why do we want to put it in Confluence? So we want to put it in Confluence because it's searchable. So for example, if I know that I'm using a particular queue, or I want to know how a queue is involved, what I can do is I can go into Confluence and do a search, and it will tell me about the different pages where something's using that, different places where that queue might be used. So in this case here I can see that I've got a message flow, And this is the message flow that's used in this queue. And I can see it's got some descriptions about it. Oh, I can see that it's actually just a sample program from IBM. Thank you, IBM. Gives me a diagram that describes the process. So I can see here this queue is used from this particular flow, and looks like it interacts with another queue called request out. I can see it's an incoming queue, so this flow consumes messages from this queue. I can see this flow, and that's where the message will go when the queue is properly processed. And that gives us that summary about that queue that we can talk to about with our users in our BAs. Now that's for an individual flow, and what we can do is for an individual flow, but we might want to go then look at our application we've analyzed just generally. So I mentioned that we had these summaries. So in this case here, we've simply got a summary here. So we can see this is a summary of our application. We can see it's got a number of different flows. So if I want to know about what a flow does, I can click on a flow. I can see the queues used, the mapping statistics. I can see these are the places, these are the different Kafka topics being used. These are the IMS request data sources being used. And then if I want to know, I can say, look, I've got looks like I've got the same piece of Java code being referenced in multiple places. Now, if you are interested in a bit more interested in how it actually works, Confluence does provide a REST API that you can download and then use that to generate a stub that allows you to interact with Confluence using whichever language you prefer, or generally binding so you can interact with Confluence whichever language you prefer, and to do these similar sort of interactions that I've shown you that we've generated with these pages. So thanks again for joining. Hopefully you got something useful from this, even if you're not an IIB developer, just to show you the sorts of automation that can be useful to help share knowledge. And as I said, this is not something that you want to be manually doing, because we want to automate as much as possible so that we can spend our time not doing like drag and dropping new diagrams. We can spend our time understanding our systems. Now, if you do want to reach out or find out more information, you can reach us on our website, bettercodingtools.com, and we have a contact page. Otherwise, you can email me at richard@bettercodingtools.com. Thanks for joining, and hopefully you will enjoy the rest of your day. Thanks again.